Hi, this lecture is about regression using the wine dataset. What we will do is that we will discuss single linear regression, root mean square error, predictions using a test set, correlation, multiple linear regression using two variables, three variables, four variables, and multicollinearity. Let's jump into the code. So the first cell is importing the libraries NumPy, Pandas, Matplotlib, and Seaborn. We read the wine dataset and we also read the test dataset. The simple linear regression, we are using only one variable here, which is AGST, which is the average growing season temperature. We create a linear regression model. Then we fit using the features, which is the AGST and the wine data price. The coefficient is only 1, the intercept is only 1. And we do the predictions here. So the root mean square error for the train set, it is the predictions minus the wine data price, and we square it and then we sum it. The loss function, it is the MSC, that is SSC by the number of observations, that is the mean square error. The metric is the RMSC, and we get it is equal to 0.478. The test predictions we can do by model.predict, and the root mean square error is 0.1888. We also will look into the correlation between the different variables. Here, this is a correlation map, and we find that what are the correlations between the variables. So, the lighter ones are highly correlated variables, and the darker ones the are the negatively correlated variables. You see here that age and France population is highly correlated. This is one of the high correlated variables. It is equal to minus 0.99. That means it is negatively correlated. And we can see it from this figure, it is a straight line and it is negatively correlated. Now, if we use multiple linear regression, that is using AGST and harvest terrain, then we do it the same way by model.fit and then the price, and then we get the mean square error as 0.426939. So we'll just see whether it has increased or decreased. So it seems that the introducing another parameter has actually increased the root mean square error. With multiple regression 2 using three variables, the AGST, harvest rain, and age, it is we utilize the same concept and we find that the root mean square is around 0.28. Now, with multiple linear regression using three variables, we see that it is AGST, harvest rain, age, and winter rain, and the root mean square is 0.186. Let's see if this is less than the one which is using a single variable. Yes, this is the least, but when we use four variables, which is AGST, harvest rain, age, winter rain and France population. Rather, uh, this was four variables before. Now it is five variables. Now we see that it is around 0.20, which is larger than using these variables HST, harvest rain, age, and winter rain. So adding this France population actually increase the error. This is due to the cause that age and France population are very correlated, and if multi and this condition is known as multicollinearity. Let's explore it with a theory. So, multicollinearity refers to the case in which two or more explanatory variables in the regression model are highly correlated, making it difficult or impossible to isolate their individual effects on the individual variable, on the dependent variable. So, here age and France population are highly correlated and negatively correlated, and therefore it increases the RMSE, the root mean square error. The lower the root mean square error, the better is the prediction capacity of the model. Therefore, we must not include the France population in the regression model and have only these four variables which we have shown: the AGST, harvest rain, age, and winter rain. So, in this way, we show that how multicollinearity affects and reduces the capacity of the regression model, and it should be avoided. So, we will not use this model because there is a high correlation between age and France population. We will not use this model, but we will use this model which uses AGST, harvest rain, age, and winter rain. Please note that this is not a foolproof method. We will discuss in further lectures concepts of cross validation, where we will prove that different sets of data will make more robust predictions with cross validation. But that is for a next lecture. But in this lecture, what we have gained is that we have seen single linear, linear regression, multiple linear regression with different variables, and we also explored the concept of multicollinearity. Hope you liked the lecture. Thank you. Bye.